Unit 6, Part 6. I'm just making sure you're paying attention. Yes, I did make a silly mistake in my calculations. So even though I've taught this 20 times, I can still make silly mistakes. Just to prove to you that you can make silly mistakes, you should always check your work, especially for exams. Okay, this was wrong. Here I got true, 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 false. So negation of that is, of course, false, 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 true. That was my screw up. All right, so now I'm looking at this and this. What do I got? False hook false is true. False hook false is true. True hook false is false. That one's false. True hook false is false. True hook true is true. Okay, so let me, right, maybe you want to do that in red pen or a different color pen for using different pens, right? True, true, false, true. That's what I got. Okay, so that's my table for that. If I just asked after this individual statement form, is it a tautology, a contradiction, or a contingency? Pause, unpause. It's a contingency because there's at least one true and there's also at least one false. It's not the case that it's all true, not the case that it's all false. Okay, so I'll first compute here. P or Q, true, 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 false, right? I'm of course looking over here at the base columns for the P and the values of P and Q to compute that. Q, let me just write it out again. It's true, false, true, false. Okay, looking at these two. T hook T is true. T hook F is F. T hook T is T. F hook F is T, is true. Okay, so that's my second one. So it's not quite clear, so it's T, T, F, T, and T, F, T, T. Okay, that's 1 and 2. You don't have to write the summary or anything, but that's what I've got. So now answer the questions. Does 1 logically imply 2? Does 2 logically imply 1? Right? Both? Neither? What's the answer? Does 1 logically imply 2? You should answer before you unpause me. No, 1 does not logically imply 2. Why? Because in this second row, you do have true going to false. So what do you think? You think, the implication, the logical implication from 1 to 2 is not truth preserving. So it is not a genuine logical implication. You're not going from true to true, right? If you were to make that inference, it wouldn't be truth preserving. It's not a legitimate logical implication. You're not truth preserving. 1 doesn't logically imply 2 because of this row. Does 2 logically imply 1? 2 can, it's possible for 2 to logically imply 1, even though 1 doesn't logically imply 2. We saw over here, 1 does logically imply 2, 2 does not logically imply 1. Here, okay, this row, row 2, which showed us that 1 does not logically imply 2, that isn't a problem for the question of whether 2 logically imply 1, because that's false going to true, but look, we have a different row here, T going to F. The third row this time is what rules out 2, which shows us that 2 does not logically imply 1, okay? Compare if we had, say, T, 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 F, T, F, F, F. So the answer to this is neither. 1 does not logically imply 2. 2 also does not logically imply 1. What if the columns came out like this, 1 and 2? Does 1 logically imply 2? No, it does not, because here and here, row 2 and 3, right, there does exist a row with true going to false. 1 does not logically imply 2. What about, does 2 logically imply 1? Yes, 2 does logically imply 1. True to true, false to true, false to true, false to false. False to true is fine, right? 2 does logically imply 1 because we don't have, going this way, we don't have any indication, we don't have any instance, any row where true goes to false. So inferring from 2 to 1 is a logical implication. You are truth preserving. What does it mean? It means wherever this is true, this is also true. It doesn't matter that this is false and then you go from false to true, it's truth preserving. It means whenever the first one is true, you preserve that truth. Wherever the first is true, you're preserving that truth, moving on to the next formula. Right? So 2 does logically imply 1 there. Okay? That's logical implication. And if you were to do the tables for these two formulas, for this rule that I was talking about, rule of simplification, you would see that there are instances where P is true and P and Q is false, right? Which is to show, right? There are instances where P is true and P and Q is false, which is the example I gave you. P is Dan is Australian, Q is a bomb drops on New York City tomorrow. That would be an example of that. So you have that shows you that P does not logically imply 2, but if you look at those truth tables, just as 2 logically implied 1 over here, there are no instances where P and Q is true and P is false. Right? So 1 logically implies 2. So that difference in the notion of logical implication, I'll probably say this again when we come to Unit 8. I will say this again in the lectures on Unit 8. The rules of Unit 7, I guess. The rules of inference. Those rules were the first rules were introduced to in Unit 7. Right? You cannot go from an instance of the bottom to an instance of the top. Right? You're not allowed to make an inference that way because the relation of logical implication doesn't hold that way. These rules are just logical implication from instances of the premise to instances of the conclusion. Right? The logical implication only works one way, downwards, not 2 ways. So you can't just create a conjunction. You can't go from some formula to that formula plus a conjunction. That is not truth preserving. You're not allowed to make that rule, which is a difference between the replacement rules, which are because the 2 formulas on each side are relations of logical implication. You can go from an instance of the left-hand side to an instance of the right-hand side, but you're also allowed to go from an instance of the right-hand side to an instance of the left-hand side. You can do that for the replacement rules. That's one of the big differences. You cannot go from instance of the bottom to instance of the top for the rules of inference. Okay, that'll all be a little bit over your head, but it's good to hear because it's really the crucial lesson for the rules. The second big difference was you could use the replacement rules on subformulas. Right? I talked about in the previous part about if you had a conditional, and if you had the consequent of the conditional is of one form in a replacement rule, either the left-hand side or the right-hand side, you could replace that subformula, the consequent of the conditional, you could replace that subformula with its equivalent formula, with the other side of the replacement rule. Not allowed to do that, not allowed to use the inference rules on subformulas. That is, if you had a consequent which was P and Q, you couldn't replace it with P. Definitely not. Right? There are many, because you wouldn't have rules which are assured to preserve truth anymore. Right? Because remember, the relation of logical implication can hold where one is true and the other one is false. So if you were to try to use the rules of inference on subformulas, you might be changing a component which is false for a component which is true, right? This is a rule, even though it's possible for this to be true and that to be false, right? So you wouldn't want to, right? You'd be replacing a subformula which is true. You could be replacing a subformula which is true with a subformula which is false, and of course that's going to affect the truth value of the formula as a whole. Because the formula as a whole is determined by the truth value of the components, but you might have changed the truth value of the component. So that's just to say why the replacement rules have those 2 differences. The second one there was you are not allowed to use the rules of inference, the Unit 7 rules, top half of the inside cover rules, not allowed to use them on subformulas, not allowed to go from the bottom to the top. All right, so the very last concept is consistency, which applies to sets of formulas. I'll come back and talk about that in the next part.